Good morning, guys. This is the second to last Monday before break, although it's kind of the last full week before we got just about 3 weeks off, and hopefully you're excited. But to start off, we've got a few lessons to get through, and again, I'm not sure if you have covered this or not, but if you get stuck, always come back to this video or ask me, your teacher, for help. Raise your hand. Okay, but here's the joke for today. What is invisible and smells like carrots? Any guesses? I know this one's right for you guys. What is invisible and smells like carrots? Well, that would be rabbit farts. Yep, rabbit farts. Okay, so what we're getting onto is more geometry stuff, and we are talking about transformations. And that is a fancy word for talking about just moving a geometric shape across a coordinate plane or a graph. So right here, we've got a few different moves, and moves are called transformations, and there's three different kinds. We have a translation, which is kind of a slide. So we have object 1 moved over here, and now it is object number 2. The other kind of transformation is a reflection, and we flip it, and they'll say reflect the figure over the x-axis. So that is exactly what's happening here. We're reflecting it across the x-axis, and just like if you're going to put a mirror there, you're trying to move it. So when we talk about our x-axis with our reflection, our x coordinates stay the same, but our y's become opposite. So for example, if we look here, we have the coordinate point -2, -4. So our -2 is going to stay the same, but instead of having -4, we're going to flip it and switch it, and we're going to have +4, which makes our point up there. So that's what you do with a reflection. You reflect it over the x-axis, the y-axis. Sometimes they may draw a line, and you'll have to reflect it across that. The rule changes. If they draw a line, you kind of just have to go with what you think in a mirror. But what I just told you about the x or the y coordinates changing, that only works if you're reflecting it over an x coordinate or a y coordinate. Obviously, if we were going to reflect it over the y coordinate, then we would keep the y's stay the same. Whatever it says you reflect, that stays the same, but your x coordinates would change. So if we were going to reflect this object, number 1, over the y-axis, our y's stay the same. So our point, for our top point here, the one that we drew, it's still going to stay at the bottom of -4. But in -2, it's going to be a +2. That's our x. See, we went over -2, and we went down -4. So now we're going to go down -4, but we're going to go over to the right too. So that would make our point here if they told us to reflect it over the y-axis. Okay, moving on. The third one is a rotation or a turn. So you're rotating the object, and they'll give you a degrees. So this is where your measuring of angles will become helpful. So here, they moved object number 1 90 degrees counterclockwise. So those kind of look like arms on a clock. That could be helpful. Or you could also put 270 degrees clockwise. It depends on how big of an angle you want to create. That's all up to you. So you can do the answers at the bottom, identify what's going on, and I'm going to move on to the next page. So now we are on Math Journal page 179, and I want to give you a few examples of what those transformations look like. So I want to do the example for you up here at the top. So it says, translate quadrangle ABCD 6 units to the right and 5 units up. Plot and label the vertices of the image that would result from the translation. So we got to move this object 6 units to the right and then 5 units up. Now what we do is we tackle one point at a time. So I'm going to tackle point A first. So we pretty much move every point to the direction. So I'm going to move point A 6 units to the right. So we got 1, 2, 3, 4, 5, 6. And then up 5 units. 1, 2, 3, 4, 5. So this is going to be our plot A. Alright, I'm going to erase these. And then I'll do B. So we go 6 units to the right. 1, 2, 3. Hold up. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Right there. Now we got B. Now let's do C. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. And D. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Okay. There we go. Simple enough. Make sure you draw the figure. Yours will look better than mine. But easy as that. Just follow the directions. And some of you are probably saying, hold up, I just need to move one and then I can figure the rest out. That works too. But again, you're going for accuracy. You're more likely to mess up if you try to just kind of go by what you see. But hey, that works for you. Alright, let's scroll down a little bit. See if there are any others that we want to cover here. Come on, keep going. There we go. Alright. Ooh, make sure you do this, try this. This is going to be a little bit challenging. You're not going to be actually seeing something. You may just need to, it's actually just working it out mathematically. So you could go ahead and try to graph it if that helps you, but try to do it just with the math. So think about the coordinates. If you're moving, for example, it says 3 units to the right here, and 2 units up. So 3 units to the right means that your x-coordinate is going to be plus 3. 2 units up means your y-coordinate is going to be plus 2. So you're really just going to be adding, so I'll give you a hint here with point W. It says point W is at -3, -2. So if we're going to move 3 units to the right, it's going to be plus 3 for our x-coordinate. So we're going to have -3 plus 3, which would equal 0. And for our y-coordinate, it's at -2. We're going to add 2, so we're going to move to 0. So that's what you're doing, just math. Okay? Maybe that's good for you. Maybe you need to visualize it. I don't know. All right, one more page, and then you guys can go ahead and off on your own. Let's see. We have reflections. So I'll do one example. So when we reflect, it says reflect. We're going to do number 1. Reflect triangle TAM over the x-axis. So here's the one that we're working with. This line. Make sure you choose the right axis. So when we reflect over the x, we want to change our y-coordinate. Right? So we're still going to go -4 to the left, but instead of going down 1, we're going to go up 1. So that's point T. Will you write? There we go, point T. Alright, then we also have A, which is also -4 to the left, but it's 3 down, so then we're going to go 3 up. So that is point A. Alright, you know it's point A. And M, -2 to the left, stays the same, but it's -3, so we got to make that +3. So that would make that point right there. And then you connect your line. And there we go. That is a reflection. So remember, we're reflecting over the x-axis, so our x-coordinates stay the same, but our y's will change. But when you do number 2, remember you're doing the y. Ooh, squeaky. You're doing the y-coordinate, so then your y's would stay the same, your y-coordinate, but your x-coordinate will change. Just something to keep out. Okay, go ahead and get working on those problems. Your assignment's up on the board. And remember, raise your hand if you have any questions. And be successful, guys. Do your best. Make sure you do those corrections when you're finished. And then Moby Max when you're done. Alright? See you in real life.